we are discussing the selection operation in genetic algorithm. Today we will discuss the few more applications, few more selection operations. In the last lecture we have discussed about two selection operations, namely canonical selection and Roulette wheel selection. We have learned there are certain limitations in Roulette wheel selection. The other selection operations that we are going to discuss it today, these are rank based selection, the tournament selection and steady state selection. So, let us first discuss about rank based selection. The rank based selection have been proposed to address the problem that is there in the Roulette wheel selection. We know that in the Roulette wheel selection, basically the individuals which has the highest fitness value is preferred more compared to the lowest fitness value. Sometimes this is not a fair selection, rather we should give a chance to select the inferior population also, because sometimes the offspring that will be produced by the mating of the best solution and then worst solution can lead to a better solution with faster termination. Anyway, so rank selection is basically based, they basically proposed to remove the biasness towards the high fitness value populations. So, in this process consists of broad two steps. So, in this process all the individuals are arranged in an ascending order of their fitness values, and then the individual which has the lowest value of the fitness is assigned as rank 1, and then the next lowest fitness value is rank 2 and so on. Once the rank is assigned to each individual, then we follow the any proportionate based selection scheme like say canonical or Roulette wheel then, and this way we will see how the favor towards the highest fitness value that is given by Roulette wheel has been checked in rank based selection method. Now, so the rank that will be assigned, it basically decides the percentage area to be occupied by a particular individual, say it is I, and the formula that we follow for this purpose is written here. So, it is the same as the fitness value or fitness score calculation that we have learned in Roulette wheel scheme. There we basically Ri was replaced by Fi there and so there. So, and this basically denoted as a Pi in the Roulette wheel selection strategy, but here it is the calculation of the rank, and based on this rank we decide the probability that it will be selected for the things. Now, here the percentage of area basically indicates, as in the Roulette wheel, that means it is the proportionate that it will be, it is eligible to select for the next generation. Now, here there may be sometimes the tie, that means two or more individuals with the same fitness value is the quite possible. In that case we should assign the same rank to the individuals. Okay, so after assigning the rank, our next task is to follow either Roulette wheel method or canonical selection method, but not based on the Pi or fitness scale there, rather it is based on this Ri, that means the rank values. Now, let us illustrate the rank based selection scheme with an example, and so let us consider only the 4 individuals at any instant, and they are F1, F2, F3 and F4, and the value is shown here F1, F2, F3 and F4. Then let us illustrate the rank based selection with an example. In this example we consider 4 individuals here, as we have shown the 4 individuals here F1 to F4 with their different fitness values, and the same populations are listed here, the 4 individuals and their fitness value is listed there. And so these are the rank that we have assigned. So the individual with the lowest fitness is here, so the rank is 1, the highest here the rank is 4, and so on so on. So this is the rank assigned for the each individual, and then on the basis of rank, and this is basically the calculation according to the rank selection method about their score. So it is basically 0.4, 0.3, 0.2, 0.1, it is basically rank divided by sum of all the rank like. So these are the things are there. Now we will apply the proportionate based any selection, say Roulette wheel, on these values there. So typically it is basically like look like this one. Now if we follow the same thing, but only without any rank, then Roulette based selection will assume these are the values. So the difference is in there, right. So Roulette wheel selection follow these are the scores, and whereas the rank selection follow these are the scores. So we can see the 80% which is considered in the Roulette wheel, it become considered as 40% of the score, and so on so on. So the score has been little bit changed because of this rank calculation and then the rank based selection strategy. So this way we can give some favors to the worst individual even. For example, earlier which has given the weightage 4%, it is basically 10%, and then also favor towards the highly fit values also reduce 80% to 40%. So this is the mechanism here it is followed, and if we follow this one, the fair chance that the inferior quality inferior individuals also will be selected compared to the superior individuals, as it is always there in the Roulette wheel scheme. So this is the basic concept of the Roulette wheel scheme, and okay, so for the implementation of this algorithm is concerned, we can explain it very briefly. So the first step is, as we have learned about, the first step is arrange all the individuals in ascending order of their fitness values. Then rank the individuals according to the position in the order, that is the worst will have the rank 1 and the next will rank 2 and then best will rank and so on. Then once the rank is assigned, we have to follow the Roulette wheel selection, but based on their assigned rank value, which will be calculated like this one. So basically Pi, you can note it, the Pi was calculated in route in a different manner, but here it is calculated based on their rank. So this is the procedure that we can follow, and now let us see how it is beneficial compared to the wheel Roulette wheel based selection. So the idea it is basically, if we follow the Roulette wheel selection, the wheel game is like this, and if we follow the rank based selection, the wheel game is like this. So it is basically rank based selection. Okay. So in this okay, so we can say that for the Roulette wheel, the fitness value having 80% has the most probable that it will be selected, whereas the probability is reduced here as the area is reduced here. So this is why in general we can say that any rank based selection is expected to perform better compared to the Roulette wheel based selection. In general, it is the result that can be obtained, and then it is proved that usually the rank based selection is better selection strategy than the Roulette wheel selection. Next we will discuss about another selection strategy. It is totally different than the selection strategy that we have discussed. Those are the basically based on the proportional based algorithm. Here we are going to discuss a new strategy based on the tournament strategy. Now, so we know the tournament strategy. Here there are different type of tournament that can be played. I have given an example here. It is basically the knockout tournament. So in case of knockout tournament, the idea it is like this: the different games are planned. For example, here is the games between the two what is called the teams is another and different games are there. Now so many games out of the different what is called the players are selected. Then so a game will be played for between the two players here. So India and New Zealand, and who is the fittest here will be selected here. So, say India is the fittest, India is selected. Similarly, another play will be played here and Sri Lanka and England. So, Sri Lanka is selected as the Sri Lanka is most fittest support compared to the England. Then the another play, okay. So, this way similarly here also Australia and here is the Pakistan is selected because of some fitness value there. Now, again another game is played and so the here India versus Sri Lanka, suppose India is the first. So, in this game India win this, and here in between Australia and Pakistan. So, in this game say Pakistan is more fittest than the Australia. So, Pakistan is selected, and finally, the play between India and Pakistan. So, here the winner say India is more fittest than Pakistan. So, India is selected. So, this way if we play the game among the different players here, and then after the end of the tournament the best the player with the best fitness values will be selected. So, this is the general procedure of the tournament selection strategy. The similar strategy has been followed in our GA operation also. We will discuss this tournament strategy in GA, and that is called the tournament selection procedure. Now, so the GA tournament selection procedure has few steps. Here we have shown the 4 steps. In this scheme, we select arbitrarily the team size n at random. That means, say suppose population size is 100 and let us decide the team size is 10 say. Then out of this 10 team we have to play the tournament as we have discussed earlier, knockout like, and then we have to select the one individual. And then if we repeat this kind of tournaments for NP times, where NP number of population to be selected for the mating pool, then we will select this one. So, the idea it is like this. Now, so this is the idea, and that okay, algorithmically this idea can be stated like this. So, input is a population of size n and their fitness values are calculated for each individual, and the output should be a mating pool of size NP, where NP is some some values less than n. So, according to strategy we have to select NU individuals okay, at random. So, you can select this NU number of individuals at random, and NU should be very large, a very small value compared to n, the total size of the population. Once the NU individual is selected, out of NU individuals we have to play the tournament, knockout tournament like, and then the individuals with the best fitness values will be selected as the winner. So, the winner which has been selected will be added to the mating pool, which is initially empty. Then we will repeat this step 1, 10, 3 for NP times until NP individuals are selected for the mating. So, this is the straightforward procedure. In fact, only the crime conjuring procedure here in the step 2, which basically plays a tournament among the NU individuals, but this is also not so costly and it is manageable and affordable. So, this is the strategy that we have discussed. Let us illustrate this strategy with an example. And so, here in this example we can see n, the total 8 number of individuals are there, and we have to select say 8 individuals for the mating pool. That means NP equals to 8 and n is also 8 here. Now, we select NU, the size of the tournament is 2 for simplicity and then illustration purpose. So, here the first trial, that means we select first n individuals from this one at random. So, selected 2 and 4 is selected. Now, out of these 2 and 4, the winner is 4 because it has the highest fitness value compared to this one. So, 4 is selected. So, this is the first trial. Similarly, second trial 3 and 8 is selected, and out of these 3 1 4.5 having the highest. So, 8 is selected. So, this procedure is continued, and these are the 8 different say population that can be selected for the mating pool. Here we have intentionally used n and NP are the same values. So, here we can see that according to this procedure, the same individual may be selected more than once. For example, here the individual 8 is selected here and here more than once. So, it is quite possible that it can be selected the same things more than once. Now, again here for example, there may be another twist, another what is called a tie also. Suppose 2 individuals selected, although all individuals are having the same value. say suppose 6 and 7, okay, suppose okay, any two individuals say 4 and 5, it has the value is 4.0, right, and in a trial if we select the individual 4 and 5 for the tournament, for example here 4 and 5 in the tournament, then both have the same value, then which I mean individual needs to be selected. So, whether 4 or 5. So, in case of tie, we can break the tie of certain tossing mechanism and then anyone at random can be selected. Okay, so, this is the tournament selection strategy, and in the tournament selection strategy what we have learned is that there is a chance for a good individual to be selected into the mating pool more than once, that we have already mentioned, and this technique found to be computationally more faster than both roulette wheel and rank based selection scheme, and it also has many other benefits. The benefits of the different selection strategy and their limitation will be discussed at the end of the lectures today. So, this is the tournament selection strategy, and tournament selection strategy also has certain twists we can follow to make it more applicable and appealing. So, there are few twists which has been hinted here. So, the NU can be changed any value as small as 2 and then as large as n. So, accordingly the different results can be obtained, and then the programmer has to choose which results is favors to give the best result and then the fastest execution of the genetic algorithm. And then another twist can be, so in that case it is repetition is allowed, we can check this repetition. This means once an individual is selected for a mating pool, it can be discarded from the current population, thus disallowing the repetition in selecting the individual for more than once. So, that is also possible if we want that only one individual will be selected only once. And another twist also can be added there in this strategy, if we replace the worst individual in the mating pool with those are not winners in any trial. So, the worst individual can be replaced by some individuals in the mating pool which are not winners in the trial. So, these are the different twists can be followed to make the tournament selection more robust and more reliable in different GA execution. Next, we are going to discuss the another strategy, it is called steady state selection algorithm. It is a very simple most strategy, it works sometimes very effectively, but not always, but it has computability is very fast, and then result is also more or less acceptable compared to the other strategies. So, some programmer follows this kind of strategy also. Now, this strategy is basically like tournament selection, it also selects one parameter called NU, that is the numbers that can be selected. So, NU can be as small as 2, usually it is very small number compared to the number of size of the population. So, NU individuals are selected and they are selected at random. So, randomly any two individuals are selected from the current population. NU individuals with the worst fitness values are replaced with the newly selected NU individuals in the previous step and added to the mating pool. So, this procedure is repeated for NP times, where NP is the number of mating populations to be selected for the mating. So, it is the procedure is like this, and if you see as the number of iterations is increased, it always refine the current population by replacing the worst. So, worst will be away from there and then all the best population will be selected, and that is giving more fair chances to the individuals with higher fitness value to be selected here compared to the worst one. So, this is the procedure, it is there, it is a simple most procedure one, but it is not so much what is called the control as it is possible there in other selection strategy, but as a simple most strategy it can be followed in some application. Now, so our objective is basically to select the individuals which can be played for the mating pool, and we have discussed that 4 different strategies, the canonical, roulette wheel, and then rank based selection, those are the population based, and then finally 2 selection are the tournament and steady state. So, 5 selection strategies that we have discussed it. Now, so there are again few what is called modifications in the selection mechanism is followed in recent GS, and this one such mechanism is called elitism. What is the main idea is that depending on the fitness values of the individuals are grouped into a number of elite group. So, elite 1, elite 2, elite n, so on so on. So, here basically the idea is that a set of individual based on their fitness value belong to the elite 1, then other is elite 2 and so on so on. In other words, the individuals which belongs to the elite 1, they are highly fit, what is called a population or highly fit individuals. So, the strategy according to elitism is that we have to move all the individuals which belongs to elite 1 to the mating pool. Then we will select the remaining in order to make the size of the mating pool as NP. So, select them from the remaining elite groups, but following some strategy either the roulette wheel or rank based selection or tournament selection there. So, this will be selected whatever the existing strategy to select the rest of the things, and then first without any selection they are moved to the mating pool. So, this is the one strategy that is followed, and it observed that this strategy is also very much effective in some situation. Now, in short we will compare the different selection scheme. So, basically the selection scheme follows the Darwin's principle of survival of the fittest. That means, the individuals which has the highest fitness value should survive better compared to the worst fitness best individual. So, this is why the selection is followed there, and all whatever the selection strategy basically targets so that we can follow the Darwin's principle there. And as we have learned it in a selection strategy, all selection strategy anyway more or less favors the selection of better individuals in a current population, and from where the mating pool can be selected. That means, it will allow mating to those individuals, they are basically the best individuals. So, assuming that from the best individuals another best offspring will be obtained. Now, in this regard any selection scheme rather can be compared, or their effectiveness can be compared in terms of two concepts. One is called the population diversity and then selection pressure. So, in order to compare the different selection scheme that we have learned, first we have to understand about what is the population diversity and then selection pressure. Now, let us understand the first population diversity, and then we will discuss about selection pressure. Now, population diversity means if the range of fitness values are within a wider range, then we say that the population has very wide diversity. So, as an example in this figure, so the range of fitness values is shown in this direction. So, this basically shows the population diversity, or in other words, if one population is this one only, then it has lesser population diversity than the entire one. So, population diversity indicates that how many different what is the wider range of the fitness values that the population currently having. Now, population diversity implies more exploration, that means we can get the more accurate result. For example, if we consider this is the one population, right, and if we ignore this one, then maybe that GA will start at with this optima. So, this is the optimum one. However, if we consider the population this one, then we may start at this one also. So, if we do not have the wider population diversity, then we may trap into local optima. So, in other words, we can say the more population diversity means more exploration. Now, next is selection pressure. So, the selection pressure is basically, what is the highest values that is there in a current population. For example, if we consider, so this is the one population, then selection pressure is this one. It is basically because highest fitness value is this one. On the other hand, if we consider this is the population, then this is the selection pressure. Selection pressure is this one, and this population has the selection, then highest values of fitness value is this one. So, here three different populations that we have considered having the three different selection pressure. So here basically selection pressure means lesser exploitation, because whenever we get the selection pressure, for example, if we take this population and selection pressure is this one, then our optimum value will be confined into this kind of things on. So basically we will not be able to exploit the better results that can be had from the if the selection pressure is something else. So this is the concept, it is here. So in summary we can say that more population diversity means more exploitation, and higher selection pressure means it is basically the lesser exploitation. So it is basically exploration versus exploitation in the mechanism. Now let us see the how we can compare the different selection scheme. Anyway, so population diversity, as we have learned, this is similar to the concept of exploration as we have already mentioned, and then selection pressure is basically concept of exploitation. This means that it is defined as the degree to which better individuals are favored. On the other hand, so far the population diversity is concerned, it means that genes from the already discovered good individuals are exploited while permitting the new area of search. So basically the idea it is there, if we follow the wider population, then we have better searching capabilities, because we can search this one also, we can search this one also, and so many direction we can search it, right. Okay, anyway, so these are the concept it is there. Now we will quickly mention few points about if the selection pressure is high or low. So first let us see, if the selection pressure is high, then the search focus only on good individuals in terms of the fitness values at that moment, and it therefore loses the population diversity, and then it basically leads to the higher rate of convergence. That means it will converge at the fastest rate, and whenever the convergence is fast, it may be premature convergence of the solution, and therefore the solution may not be so accurate. So there is a basically trade off between the selection pressure and the population diversity here. And on the other hand, if the selection pressure is low, so it may not be able to drive the search properly, and consequently the stagnation may occur, and the convergence rate compared to the selection pressure is high is low, and GA takes unnecessary long time to find optimum solution. Accuracy of solution, however, if the selection pressure is low, increases as more number of individuals are explored in the search process. Now I will just this is the last slide, and I will quickly summarize the different what is called the techniques there in terms of population diversity and the selection pressure. Now as the table says that, so for the Roulette wheel selection is concerned, it provides low population diversity, whereas selection pressure is high. On the other hand, in case of rank selection, it favors high population diversity, and then selection pressure is low. And if we consider tournament selection, population diversity is moderate, and it provides very high selection pressure. Steady state selection, on the other hand, population diversity decreases gradually as the number of generation advances, where the selection pressure is too low. So this comparison gives us enough idea about which selection strategy are to be followed. If we want that high population diversity, and then definitely we can go for tournament selection. On the other hand, if we want very high selection pressure and then population diversity low, then we can choose for Roulette wheel selection strategy. So these are the different selection strategy that is there in the GA theory we have discussed in this lecture, and we will discuss about other operators also there. It is basically called the generation gap. Generation gap is denoted by P by N, where P is basically the number of individuals, those are basically will be replaced, and N is basically the number of population, is the size of the population. Now for example, in case of steady state selection, the GP equal almost 0. that means because if we take nu equals to 2 and for a large population size. On the other hand, for other selection strategy Gp equals to very high, it is as high as 1. So, that is the maximum value and the lowest value is 0. So, Gp lies between 0 and 1, and Gp also can be considered as a measure about a selection strategy, and it is usually preferable that selection strategy which has better generation gap. So, in that case steady state selection is not favorable because generation gap is very less. Okay, we have considered the different selection strategies here, and our next topics that we are going to discuss is another operation, another GA operator, it is called crossover operation. Okay, thank you.